Welcome to the last chapter in Mechanics Year 1, Chapter 11.5, where we look into how we derive the constant acceleration formulae that you learned in Chapter 9 about kinematics. Actually, it could be derived from using integration. So in Chapter 9, you've learned about different Suvat formula, right? Using a velocity time graph. So v equals u plus at, s equals ut plus half at squared. So actually, these could be derived from using integration, provided that we consider the acceleration is constant, and that's why these formula are assumed acceleration is constant. So acceleration is constant means acceleration is a number. Okay, so a equals just a number. All right. So given a body moves with constant acceleration, okay, we call this a. Okay, so this is a meter per second squared. So this is constant because a does not equal to a function of time. That means a cannot be written as an equation of time. So when it's a function of time, means a could be written as an equation, as an expression of time. But here it's not. A is just a number. All right. So the initial velocity is u meter per second. Now this is a boundary condition. If you don't remember what is a boundary condition, you can go back to the chapter 11.4 video. Boundary condition essentially is a piece of information given by the question to you to help you work a value of c. Okay, extra information. So initial means t equals 0. Velocity is u, so v is u. That's what it means. Okay, so when t equals 0, velocity is u. All right, next one. Initial displacement is 0. Are you able to write down the boundary condition for this one? T equals 0 and s equals 0. Yes, even the Dora Explorer can write this. Right, so part A. So prove v equals u plus at. Okay, so the formula start with v equals something. So we start with since v equals integral of a dt, therefore v equals to at plus c. All right, and then we can use the boundary condition when t equals 0, v equals u. So v equals u. So v is u, a times 0 plus c. So c equals to, so that's 0, so c equals to u. Cu, so v equals to at plus u. Don't like this. Okay, therefore v equals u plus at. Happy. All right, that's one. All right, next one, part B. Prove that s equals ut plus alpha at squared. Okay, so since s equals to, what is s equals to? Integral v dt. Then what does that mean? That means s equals to, so we know v is u plus at, so integral of u plus at dt. So integrate u, ut. Integrate at squared over 2. Plus, I'm going to use plus d because in the same question I've used plus c already. Just to stop confusing people, I use plus d in here, but it's the same thing as plus c. Next, we can apply the boundary condition. So when t equals 0, s equals 0. You can see where it's coming from, where it's coming to. So 0 is equals to d because 0 equals 0 plus d. So d is 0. Therefore, s equals ut plus a half at squared. Double smiley face. Why does it look a bit evil? Anyway, right. Yeah, one more example. It's the last chapter for mechanics, so put a little smiley face to celebrate it. Example, a particle moves in a straight line with constant acceleration. All right. The initial velocity of the particle is 5 meters per second, and then after 2 seconds, it's moving with 30 meters per second. So part A, find the acceleration of the particle. If you want to pause video, have a go at the question A and even B, feel free, pause video. Part A. Now, this has nothing to do with actual integration or anything. Constant acceleration means use Suvat. Okay, unless in part B they want you to use without making use of a kinematics formula. Otherwise, you're free to use Suvat. So part A, okay, let you start the question. Right, so we know S, we'll find acceleration first of all. The initial particle is 5, initial velocity is 5, so u is 5. After 2 seconds, c is 2, v is 13. To find A, we know v equals u plus at, so 13 equals 5 plus a times 2. A equals 4 meter per second squared. Even a 5-year-old can do the mental maths quicker than you. Right. So actually, let me double check. Yeah, it's correct. Imagine I got wrong. Part B, without making use of kinematics formula, that means we can't use any of the Suvat. show that the displacement s meter of the particle from its starting position is given by s equals pt squared plus qt plus r, where p, q, and r are constants to be found. Now, for those OCD people where you find, oh, why is the font different? I do apologize for that. In Word document, which is when I start typing out their formula in here or the Microsoft OneNote, whatever, when you type in formula, a mathematical formula, they change into certain type of form, a font like this one here. And sometimes there's a glitch when you type it again, it won't let you change to the original. That's why. Anyway, it doesn't matter really. So we know, okay, so since, now how do we start the question? You might be thinking, just like the previous one, since s equals integral v dt, let's start from there. Okay, so, but we don't know what v is. Okay, so, but what's v? Since s equals integral v dt and v equals integral of a dt, okay, we start from v equals a dt. So v equals integral of a dt, a is a constant. So in here, v equals to integral of, so therefore integrate a, give at plus c. All right, and what do we know? A is 4. A is 4. So v equals to 4t plus c. So in here, 4. Okay, why can we substitute? So why can we substitute? Why a equals 4? Because a is constant in this question. That's why we can substitute 4. Normally we can't, but now this one we can. All right, what else do we know? We know initial velocity is 5 meters per second. So when t equals 0, v equals 4. That's what we're told, right? So v equals 5, sorry, v equals 5. I can't read. V equals 5. So let's type it in. So 5 equals 0 plus c, c equals 5, so v equals 40 plus 5. And guess what we need to do? We know s equals integral v dt, so s equals integrate 4t plus 5 dt. So let's integrate. So s equals 4t squared over 2 plus 5t plus d. So let's simplify. S equals 2t squared plus 5t plus d. What else do we know? There's something hidden here. Okay, so you might be thinking, okay, so how do we find d? Are we given any boundary condition about s and v? S and t between displacement and time? Well, you can see we're not. However, there's a hidden one, which is here. When t equals 0, s equals 0. Now, this is the hidden one. Because when you start from the initial position, they didn't say where you started off. So displacement, where you started the journey will be your initial displacement, which is 0. That's where you always measure from. Unless they tell you otherwise, they say when t equals 0, s equals 15, s equals 5, s equals 10. But in this case, if they don't tell you anything, when t is 0, displacement, initial displacement, always 0. Because that's where you are. And whatever displacement you're measuring, you always measure against the original point, which is 0. Right? So that's a hidden one. Tricky? Not quite. So if you know this, now you know. So 0. If you don't know this, now you know. So 2 times 0 plus 5 times 0 plus d. d equals 0. So therefore, s equals 2t squared plus 5t. And what do you know about p, q, and r? So therefore, p equals 2, q equals 5, and r equals 0. And that's the end of Year 1 Mechanics. Bye for now.